So in this video, we're going to talk about Pythagorean Theorem word problems. Alright, so here's the problem. The bottom of a ladder must be placed 3 feet from a wall. The ladder is 10 feet long. How far above the ground does the ladder touch the wall? So to solve this, we're going to illustrate it. And let's analyze first the problem. So we have the bottom of the ladder must be placed 3 feet from a wall. So we're going to have the ladder and then the wall where it is 3 feet from the ladder, from the bottom of the ladder. And it says that the ladder is 10 feet long. So we're going to put here 10 feet because that's the length of the ladder. And how far above the ground does the ladder touch the wall? So from the ground going to the top of the ladder. So that is what we are trying to look for. So now we're going to solve this using the Pythagorean theorem, which is saying that a squared plus b squared equals c squared. So I'm going to explain to you what is this. So a Pythagorean theorem is used to solve problems involving right triangle. So if you don't know what right triangle is, it's a triangle where one side is exactly vertical and the other side is exactly horizontal. So they are perpendicular to each other. If you know what perpendicular is, they're forming 90-degree angle. And the longest side, which is what you call the hypotenuse in this problem, is the ladder. It's right opposite to the 90-degree angle. And the remaining are the shorter side. So in this equation, a squared plus b squared, the a and the b are the shorter sides, while the c is the hypotenuse. So based on the Pythagorean theorem, the sum of the square of the shorter sides, which is in our problem, it's the ground and the height of the wall, is equal to the square of the length of the ladder, or the hypotenuse. So this is the concept of the Pythagorean theorem. As long as it involves a right triangle and given the sides and one side is missing, so you can use the Pythagorean theorem. So it's named Pythagorean theorem because it coming from the mathematician name Pythagoras. So we have a squared, which is the missing. We're gonna name it a squared, or you can choose the b squared, either of the two, plus 3 squared because it's the other shorter side. So we're gonna name it, we're gonna replace it there as 3 squared, and then equals, and then the hypotenuse, which is 10 squared. It's the longest side. So as I said, you can interchange the a and b because both those are interchangeable. The a and b are the two shorter sides, which are the vertical and the horizontal sides of a right triangle. And then we are going to let's just copy the a squared and then take the squares of 3 and 10. So what does it mean by square? It means you are going to multiply it by itself. So it's 3 times 3. And for 10 squared is 10 times 10. So 3 times 3 is 9. So we'll just copy the plus and then 9 equals square of 10 is 100. 10 times 10 is 100. Then solve for a. So if you say solve for a known variable, we're going to separate those with a and without a. So since 9 doesn't have a, so we're going to remove that by subtracting 9 both sides, so that we can cancel it since 9 minus 9 is 0. So what's left at the left side is only a squared, where on the other side 100 minus 9 is 91. Now, we're not done yet since a has a square, so we want to remove it because what we are after is only a. So we're going to take the square root on both sides in order to remove the square. So to neutralize the square, we're going to put the square root so that it's only a being left. So it's like 2 squared. 2 squared is 4. if you take the square root of 4, then it will go back to 2. So it's just simply square root of 2 squared is just 2. So in this case, square root of a squared is just a. And square root of 91, if you have a calculator, you can use that where you can have the answer 9.54. Of course, it is not exact. It is a long, probably a long answer, so you can just approximate the answer. That's why I'm using approximately equal to, since we are rounding off to 2 decimal places. And then don't forget to put the unit. So it's all the given are in feet, so we're going to put feet. So it's 9.54 feet. Now another example is this one. A soccer field is a rectangle 100 meters wide and 130 meters long. The coach asks players to run from one corner to the other corner diagonally across. What is that distance? So to solve this, let's illustrate it first. We have a soccer field and 100 meters wide, 130 meters long. And the coach asks players to run from one corner to the other. So let's say it's here. And that is the question. How long is this diagonal? So obviously it forms a right triangle, since it's a rectangle that's cut into half, and rectangle is forming a 90-degree angle, and one side is vertical and one side is horizontal. So we don't know how long is the diagonal. So let's use the Pythagorean theorem, where it's saying that the sum of the squares of the two shorter sides is equal to the square of the longer side. So let's put both shorter sides, 100 squared and 130 squared. And the hypotenuse, as I said, that's the longest side of the right triangle. So it's missing, so we're going to solve that. So 100 squared, it means 100 times 100. That's 10,000. And then 130 squared is 130 times itself is 16,900. Then just copy the plus. And then we'll just copy the one on the right side. Now we're going to combine 10,000 and 16,900. So it's added. That will give you 26,900. And then copy the c squared to the right side. Now to remove the square, we're going to take the square root of both sides, so that the c squared will become only c, since the square is being cancelled because of the square root. So it will become c, and then on the other side, square root of 26,900. If you use a calculator for that, it will give you 164.01 meters. So that is the length of the diagonal. If your answer is smaller than 130 or smaller than 100, that is impossible, because the diagonal should be the longest, since it's the hypotenuse. It's opposite to the 90-degree angle. It should be the longest side. It shouldn't be equal or shorter than the remaining two sides. Now we still have one more example. We have David leaves the house to go to school. He walks 200 meters west and 125 meters north. How far away is he from his starting point? So again, to solve this, we are going to illustrate it first and understand it sentence by sentence. So David leaves the house to go to school. So we have a house, and then he walks 200 meters west. So it's here, going to the left, and 125 meters north. So going up 125 meters. How far away is he from his starting point? So it's saying that he leaves house to go to school. So I'm going to put the school there. And this is what it is looking for. It's the distance from the house to the school. Direct, not going to the left and up, meaning the total distance. It's asking for the exact distance from starting point, which is the house, and the school, unless it's asking for the total distance traveled. Then you just need to add 200 and 125. So it's a kind of tricky problem. So again, it's saying that it's how far away from his starting point, so it should be the direct distance. It's also what you call displacement. So we're gonna put the equation for the Pythagorean theorem. Again, it's saying that the sum of the squares of the shorter sides is equal to the square of the hypotenuse, or the longest side, which is the one missing. So let's replace one of the shorter sides. So we have 200 squared plus 125 squared, or you can interchange the two. It doesn't matter. It's the same answer. Equals the hypotenuse, which is c squared. So the only thing that you cannot interchange is the hypotenuse. It should be the one at the right side, which is the one that's not being added. And again, it's the longest side. So square of 200, or multiplied by itself, 200 times 200, so you'll get 40,000. While 125 squared is 15,625. And then copy the c squared. So let's combine the left side, 40,000 and 15,625. That will give you 55,625. Now we still have square on c, so we're going to take the square on both sides, which is the same as the previous example. So that the square of c will be gone, since we take the square root of it, and take the square root of 55,625. So it will be 235.85, and then put the unit meters.